All right, Mr. Woodard, spelling out the word whole when talking about Gestalt theory, W-H-O-L-E-S, made me think Gestalt theory turns holes, H-O-L-E-S, into wholes, W-H-O-L-E-S. Or there might be holes in a photo or a picture or some sort of image. Our brain wants to create an entirety, a whole, W-H-O-L-E-S. So he ended up on that slide talking about the law of similarity. Continuing on with that, we can go with that image there with the circles and the squares. Do we see columns? Do we see rows? No, most of us just see the triangle of circles because we put those circles together as a whole. Continuity, Mr. Woodard already talked about this one. Again, are they four lines all intersecting at the same spot? Is it two continuous lines? Most people will see two continuous lines there. And then Mr. Woodard mentioned the law of common fate. This is a really fun one. Now, obviously, artists use this one oftentimes. So the law of common fate is going to state that if there are lines that appear to have the same trajectory, they have the same ending point, they're traveling together, then we group them together. So you can see here on the left, it looks like these lines almost like a road going off into the distance. I thought this one was a really fun one there. We see these almost as traveling together, so we have a tendency to group them together. The law of common fate. Subjective contours is kind of a famous one. This is the World Wildlife Federation logo, and they use subjective contours in this logo. There are no boundaries that are actually visible here. Our brains fill in the boundaries so that we see the panda bear, even though those contours are completely subjective. Those are our brains filling in those contours so that we can actually see the panda bear's back and his head. Going closely related to subjective contours is the law of closure. So we see three different images here, a square, a triangle, and a circle. Although they're obviously very broken, we can see those as an entire shape. So subjective contours, there's no contour that is visible. We just fill them in. Closure is when that you have a shape or some sort of gap, and we'll fill those in to make sure that we have a complete figure. All right, now we're going to move into depth perception, and we have monocular clues and binocular cues for depth perception. Monocular clues, just think of your roots and stems, just needs one eye for it to work, for us to be told that there's some sort of depth going on there. Binocular clues need both eyes. Now, both of our eyes are working, and they're working simultaneously, and they're working together. The monocular cues simply just, they need one eye, even though both eyes are working together. Okay, now, for this particular slide, there are several things that we're going to need to show you in class, so I'll explain them. I'll show you one of them. Hopefully the explanations will get you rolling on them. So relative size, things further away are smaller. Think in terms of when we, I think off the Sky Bridge, you can look off into the distance and see Mount Spokane. Mount Spokane is a mountain, but because it's so far away, it looks smaller. So relative size, our brains are saying, okay, that thing is it looks really small, it must be far away. Light and shadow. There's a really good video that we'll show you in class. Hopefully we'll have some time to show you that. If you think, artists again use this oftentimes, if you think of somebody drawing the moon, so it's a completely 2D representation, it's on a piece of paper. However, once they start using shadow to create the craters in the moon, it looks like it's a 3D object. Light and shadow, that's a monocular cue giving us some sort of depth for the moon, even though it's a 2D object. Interposition, there used to be a great Canadian comedy show called The Kids in the Hall, and they had this little skit, and it sounds so silly, but it was hilarious back in the day, and it was, I'm crushing your head, and a lot of people know this one anyway, I'm crushing your head, I'm crushing your head. So nearer objects hide further ones. So when I do this, and this one, you do have to only use one eye. If you use two eyes, actually one of the binocular cues comes in and it won't work. So a monocular cue, I am crushing your head. You can crush Mount Spokane. I can crush the house across the street. Why? Because the nearer objects are hiding a further one. Relative motion, anybody that's ever driven down a highway and looked out the window, it looks like the things that are nearer to you look like they're going by faster than the things that are off in the distance. You're traveling at the same speed, obviously, but your brain is saying, oh, those things must be closer because they look like they're going a lot faster. There's a couple of good videos that we'll have to show you for that one. Atmospheric perspective. Okay, you ready for this? This slide is going to look really odd. It's going to look really busy all of a sudden, but let me explain. With atmospheric perspective, you can see that the mountains off in the distance almost have like a light blue, almost purplish tint to them. And then, the ones that are closer look darker. That atmospheric perspective, and again, artists use this all the time, tells us that, oh, okay, our brains are saying that light blue must mean that those are far off in the distance, again, helping us with our depth perception. And you can also see interposition with this one because the person that's holding out whatever they're holding, the cards or whatever, look like they're blocking all of the stuff that's in the background. That's just the nearer objects are blocking away the things that are farther away. Okay. Now, binocular clues. This is kind of a fun one. It hurts just a little bit, not too bad. If you put your finger, this is called binocular convergence. You can actually feel this one. If you put your finger out in front of you and just slowly move it closer to you, you can feel your eyes literally rotating in. They're converging in on that particular finger. This is telling your brain, hey, that finger is getting closer. Your brain is actually registering the eye movement, and it's figuring out that eye movement. It's telling it's creating meaning out of that how close that finger is, and saying, okay, that's the depth perception because I know those eyes are rotating in, so that object must be getting closer. And retinal disparity, this is always a fun one. I don't know if you have a clock. We do this with a clock in the classroom. You can just take your thumb and put it over something. You know, there's a smoke detector on the ceiling over there. I'm just going to do it like that. And you close one eye and then close the other eye. And it looks like your thumb moved away and you're not covering up the smoke detector or the clock anymore. Okay. Because your eyes are separated on our face, we're constantly seeing the world at slightly different angles. The brain is interpreting those slightly different angles and telling us how far away something is based on that retinal disparity. Based on the angle, the difference in angles that our brain is simultaneously taking in, it's able to understand that something is farther away than something else. Okay? Again, we'll show you some of these in class. We're not going to worry about this one right now. Now, we've talked about this before. Sensation versus perception. So perception allows us to understand whatever it is we're sensing. We saw it way back on that very first slide with the jumbled paragraph, and the sensations that were coming in told us one thing, but our brains immediately made meaning out of it, and we were able to understand what that perception was. Okay? We perceived that sensation. We made meaning out of it. Sorry, there we go. So we get something like this. Our brain wants to make meaning out of that. What does that say? Most people know. Or do you? Okay, our brains are making meaning out of some sort of sensation. We've talked about perceptual constancies, but I'm at, well, I'm about 9 minutes. I'm going to go ahead and wrap it up. Let Mr. Woodard finish up our perceptual constancies, and then I think he'll be able to, he's got a couple of probably pretty cool visual illusions for you, and then he'll get into hearing maybe. By the way, we started with a simple University of Miami hat, then all of a sudden we got to wigs. That escalated quickly. So before we sign off here, this is my Nepalese hemp hat. My sister-in-law got this for me when she was in Nepal years ago. It's one of my favorite hats. It's super comfortable in the summer. So Mr. Woodard, it's on you now.